All right, welcome ladies and gentlemen. This is video number 2 for our Redox unit. You're going to need your notes open to page 4 for this, and in this video I'm going to be talking about how to tell if something is oxidized versus if something is reduced, and also how to balance these things called half reactions that only show oxidation or reduction. So first up, how to tell what's oxidized and what's reduced. It's a 3-step process, and we're going to use this process many times throughout the unit, and in doing different things, it's always going to, the first step is always going to be the exact same thing. Write the oxidation number for each element in the reaction. Because this is the basis of how we tell what's oxidized, what's reduced. We look at the change in charge. How did the charge change? So we have to start. Our first step has to be figuring out, hey, what's the charge? Because you can't figure out how the charge changed unless you know what the charge is first. So write the oxidation numbers for each element on both sides of the arrow. So we have this example reaction here, 2H2 plus O2 yields 2H2O. And we want to work out what was oxidized, what's reduced. Start by assigning oxidation numbers. Well, on the left side of the arrow, I've got 2H2 plus O2. By the way, coefficients do not matter when you're assigning oxidation numbers. We don't care at all that we have 2 hydrogen molecules. We do not care at all that we have 2 waters. It makes no effect on assigning oxidation numbers. Let's start with the hydrogen and the oxygen on the left side of the arrow. They're both elements that are alone. Yes, we have rules for them when they're in a compound, but they aren't in a compound here. They're by themselves. They're not bonded to any other thing. They're alone. And when an element is alone, its oxidation number is 0. So both of these elements are starting with a charge of 0. They're starting at neutral because they're by themselves. But then we also have to assign the oxidation numbers to the stuff on the right side. You can't just assign oxidation numbers on one side. You got to do it on both sides. So now we have hydrogen and oxygen that are bonded together, and now the rules changed because now they're not alone. So now we're going to our other set of rules. The fact that hydrogen is almost always +1 in a compound and oxygen is almost always -2 in a compound. So we have assigned oxidation numbers. The hydrogen and oxygen start by themselves with a charge of 0, and then they end being in a compound and they have different oxidation numbers. The second step is to show the change in oxidation numbers, basically to kind of look at what you just wrote and say, hey, you know, how did each thing change? So we have 2 elements here. We have a hydrogen and we have an oxygen. And I just want to state the change. So the hydrogen, I look at the hydrogen started at a charge of 0, and then it ended at a charge of +1. So I'm just going to write that. I'm going to say the hydrogen went from 0 to +1. Because that helps me kind of really see the change. The hydrogen went from 0 to +1. The oxygen, on the other hand, it started at a charge of 0, but it ended at a charge of -2. So I'm just going to write that. Oxygen started at 0, went to a charge of -2. Okay, just sort of summarizing. Hey, this is the change in oxidation numbers. Next step. Now, this is sort of the big one. Use our definitions of oxidation and reduction. Work out which element was oxidized, which element was reduced. Now, remember the phrase, Leo the lion says grr. Leo the lion says grr. L-E-O, loss of electrons is oxidation. G-E-R, gain of electrons is reduction. Massive, massive point. Oxidation, because it's the loss of electrons. Electrons are negative, right? Electrons are negative. You lose a negative charge, you become more positive. So in oxidation, charge increases. It becomes more positive, right? And I've got a number line down here, right? Oxidation, you could start at, let's say, a charge of -3, and anything that moves you, again, towards this increase, anything that moves in this direction would be oxidation. Reduction, on the other hand, is the gain of electrons. Electrons have a negative charge. If you add more negative onto something, then the overall charge becomes more negative. So in reduction, charge decreases. The charge goes down because you made it more negative. We are moving now in this direction on the number line, right? If we started at a charge of +3, anything that moved us in the direction towards decreasing, right? Decreases is this direction, would be reduction. Reduction, charge goes down. That's actually why they call it reduction. You're reducing the charge. So when we look again at our elements now, we had hydrogen that's going from 0 to +1, and we have oxygen that's going from 0 to -2. Right? And it's about figuring out the direction that they're going, essentially from the number line. So our hydrogen is starting here, but it's going here. This is an increase in charge. This indicates that electrons had to have been lost because the charge went up. The hydrogen became more positive. So your hydrogen underwent oxidation. Versus the oxygen went from 0 to -2. So again, the oxygen, it started in the same place as the hydrogen did, but now it went in this direction on the number line, right? It went to a -2 charge. That's a decrease in charge, right? Charge went down for the oxygen. The only way that happens is if you add negative electrons onto the original oxygen, you make its charge get smaller. This is reduction. The oxygen was reduced. Its charge was reduced. So we're going to look at one example of this, and then we're going to talk about balancing half reactions. So we have another example, 2HI goes to H2 plus I2. We want to figure out what was oxidized, what's reduced. First thing you want to do is assign oxidation numbers. This 2 out in front doesn't matter. I'm going to start with the HI. I have a rule for hydrogen. Hydrogen in a compound is usually +1. That means that the iodine has to be a -1 charge in order for charge to balance, in order for charge to cancel out. Also, we do have a rule that halogens are -1 when they're in the binary compound, which this is. But then on the right side, I have hydrogen that's alone. Hydrogen that's alone is going to have an oxidation number of 0. Likewise, iodine that's alone is going to have an oxidation number of 0. So that's my first step. I assigned oxidation numbers. Now I'm just going to kind of summarize what I see, and I see that the hydrogen starts at a charge of +1, but it ends at a charge of 0. So I'm just going to write that. Hydrogen goes from +1 to 0. And the iodine starts at a charge of -1, and it ends at a charge of 0. So the iodine goes from -1 to 0. And now I want to decide is which thing is oxidizing, which thing is reducing. Again, in oxidation, charge increases. In reduction, charge decreases. So it's all about what's happening on the number line. So hydrogen is starting at a +1 on our number line, but then it's going to 0. This is a decrease in charge. Versus the iodine, which is actually starting at this charge of -1, but now it's moving to a charge of 0. That's an increase, right? Even though there are no positives here, it went from something negative to something that's neutral. So this is an increase in charge based on the direction it moved on the number line. Well, a decrease in charge, you only get that if you added electrons. So this was reduction. The hydrogen underwent reduction. Its charge decreased, its charge was reduced. And the iodine went from a -1 to a charge of 0. The only way that happens is if the iodine lost the negative electrons. So this had to have been oxidation, right? It loses a negative, it became more positive. Now, balancing half reactions. So that's the first bit. And now we're going to talk about how when you have a half reaction, how do you make sure it's balanced? Now, the key to making sure that you have this right is to basically be following the law of conservation of charge. Make sure the charge is the same on both sides of the arrow. And the way that we're allowed to do that is to add electrons. That's the only thing that we can do. It's the only thing that we can do in order to balance charge. So we have this half reaction. 2O, 2- yields O2, and I'm just going to rewrite it a little bit larger, like that. We want to make sure the charge is the same on both sides. We want to make sure this is balanced. So the first thing I'm going to do is work out what is the total charge on both sides of the arrow. So it's a little bit of assigning oxidation numbers, a little bit of looking at this reaction. Now the coefficient does matter. There are two O2 minuses. So that's like saying O2 minus plus O2 minus yields the oxygen, right? Okay, I think this is a good and important thing to do because then you can see what's the total charge on the left side of the arrow. Well, I have a -2 here plus a -2 here. So that means that I have a total of a -4 charge on the left side of the arrow. Now, what about the right side of the arrow? Assign oxidation numbers. This is an element that's by itself, right? So its oxidation number, it's just 0. So I have a charge of -4 on the left, and a charge of 0 on the right. That's not the same. And we have to make sure that charge is the same on both sides, otherwise we don't have a balanced half reaction. So what are we allowed to do? We're allowed to add electrons. Well, hopefully you can see that in this case we want to add 4 electrons because we have -4 on one side and we have 0 on the other. The question is, which side do you add the electrons onto? Well, the nice thing is you only have 2 options, right? The left side or the right side. That's it. And you can check and make sure if you were right, and if you weren't right, then it must have been on the other side, right? You have a 50-50 chance. You can sort of take a shot, try it out, and then see if you were correct. But because electrons are negative, you're always going to add electrons to your more positive side to basically bring that charge down to meet the other side. So because I have a -4 here, I need to decrease the right side until it gets to a -4 charge. So if I add 4 electrons here, now I don't have a charge of 0 on the right. Now I have a charge of -4 on the right. 0 plus the 4 times -1, which is going to be equal to the -4 that I already had on the left side. If I had added 4 electrons to the left side, then I would have had actually a -8 charge on the left and only a 0 charge on the right, and so that certainly wouldn't be balanced. So this thing right here, and I'm just going to rewrite it in the original thing, if I put the 4 electrons right there, this is our balanced half reaction. And then the final question I would say is this oxidation or reduction? Well, what's happening to the charge on the oxygen? The charge on the oxygen is going from -2 to 0. That's an increase in charge. Charge is going up. So this is actually an oxidation half reaction. And my markers are freaking out, so I'm just going to go to the next slide. So just two more examples of that. Balance the following half reactions. We have magnesium goes to Mg2 plus and Al2 plus goes to Al0. We want to figure out charge on both sides, right? So charge on the left side right now is 0, and the charge on the right side is +2. That's not the same charge on both sides, so it's not balanced. How many electrons do I have to add? Because that's how I balance charge. Well, I have 0 and I have +2, so I'm going to be adding 2 electrons because the 0 and the +2, they're 2 steps away from one another on the number line. Which side, though, am I going to add them onto? Again, electrons are negative, so you're always going to add electrons to your more positive side. +2 is more positive than 0. So if I add 2 electrons to that side, now I have +2 plus a -2. 0 is equal to 0. I have the same charge on both sides. Now I do have a balanced half reaction. And then my follow-up question is just, is this oxidation or is this reduction? Charge is increasing, right? The magnesium's charge is going from 0 to +2. That is oxidation. So this is an oxidation half reaction. Charge is increasing, and adding the 2 electrons makes it balanced. And then this last example, aluminum +3 goes to aluminum 0. Figure out charge on both sides. I have +3 on the left, and it's going to 0 on the right. Charge is not the same on both sides. This is not a balanced half reaction. I have to balance it. I have to add electrons. That's the only way I can balance it. And I have to add 3 electrons because I've got a difference between +3 and 0. There's 3 spots away from one another on the number line. I want to add my electrons to the more positive side in order to make it more negative, to sort of meet the more negative side. So if I add 3 electrons over here on this side, now I have a -3 plus a +3, which is equal to 0, and I do have the same charge on both sides. So I do have this balanced half reaction, which is good, which is what I want. And then is this oxidation or is this reduction? In order to determine that, again, look at the charge. The aluminum's charge is going from +3 to 0. That is a decrease in charge. That is literally, by definition, reduction, because that's what reduction means. I mean, it's the gain of electrons, but when that happens, the charge gets reduced. So we're going to practice a lot. Don't worry if this seems like a lot right now. We're going to practice a lot in class about figuring out what was oxidized, what was reduced, and balancing half reactions.